Hi everyone. Today's video is going to be about Rainbow Kitty. It's an environment I made in Unity 3D with ML agents. I'm going to go ahead and show you guys what the environment looks like, how I trained it, and the kind of results that I've gotten. We're going to go kind of quick because this is just a project demo video. Okay, so I've made this wonderful environment. I basically just have a giant plane here that's black, just to sort of look nice and do some other things in the code for me later that I'll explain. But the main point of this are these cubes. So I have a bunch of these little cubes here, and they're each colored a different colored tile. And I've just kind of arranged them in this configuration. And you'll see over here that I got this adorable little rainbow cat. He's in the shadows, so it's a little bit hard to see. But here's Rainbow Cat. And Rainbow Cat is going to be our agent. And the thing that's special about Rainbow Cat is that he can actually see. He has cat vision. So you can see this field here that comes out. This is the camera that is attached to Rainbow Cat. And if we switch to display 2 during game mode, we'll be able to see this camera preview, which is actually going to be the input for our agent. So Rainbow Cat doesn't get any more information besides the vision that he has and the rotation. It's important for Rainbow Cat to kind of know which direction he's looking at. So this is the environment, and during training, we have trained to randomly drop Rainbow Cat on one of these tiles. Each of these tiles has an associated tag with it, and Rainbow Cat has to go to hopefully the closest colored tile. It can go to any colored tile, but hopefully the closest one. So let's go ahead and take a look at how we set up the code for Rainbow Cat. So I'm just gonna zoom in here so you guys can see. So I just start like a regular Unity environment. I have a rigid body on the agent as well as a box collider, and I have box colliders on each of the tiles. So that's going to be important for later. So basically, we just start up this new episode by dropping Rainbow Cat in some random location on the color tiled space, and we stop his velocity so he's not moving. And then we need to find which tile we landed on. So there's some very complicated code to do that. It's probably not the best way, but it works here. So I have that, and then we're going to collect the observations, just the rotation of the agent, and the camera sensor is automatically added to the ML agent's collect observations. And the actions that the agent is capable of taking is this horizontal input, vertical input. So basically, if the agent falls off the color tile platforms, then it's going to receive a negative reward of -1, and the episode will end and the whole thing will start over. And so I also wanted to say if we get to another tile that is the same tile that we landed on, go ahead and set the reward to 1, and that means we reach the target. And I'm I made the Unity environment play this little noise because I like listening to it train. I highly recommend you do this. Anyways, so if it gets to the target, then it'll end the episode and off we go on another task. And it's always a good thing to do is put your heuristic in here so you can figure out what's going on. And let's go ahead and talk about the configuration file for training. So I train this with proximal policy optimization and with soft actor critic. So these are my hyperparameters. I have a fairly small network. The batch size is smallest as recommended. Buffer size is as recommended. Everything's pretty standard, only 2 layers. I'm using extrinsic reward, and this does pretty well. So I think something like a deep queue network might work better, but I just wanted to go ahead and get the environment up and running as a proof of concept before I really dug in behind the brain of the agent. So I want to show you guys real quick. Oh, here's a good thing to know. If you ever are confused about how to set up your configuration file, you can go to Unity ML Agents GitHub and figure their training configuration file, markdown file that they have in their GitHub, and it has so many really useful tips and information. this is how I do my configuration files. So I would definitely take a look here if you're trying to set that up. All right, on to the results. So these are some of the things I trained. I don't even have all of them on here because honestly, I just tried so many things for this Unity environment that it got kind of a little much for TensorBoard to plot on here. But you can see that most of them are up here in this range. That's doing pretty well. So there's a small negative reward for existing. That's why you're seeing that the cumulative reward is still in the negative, but it's getting pretty close to zero, which means the agent is walking around a bit, which is to be expected. Sometimes the agent's going to have to walk across a couple squares to get to the closest colored, same colored tile. And as you can see, I did want to show you guys something actually I found that was really interesting. Um, so if we just take a look at the same two basics, like I have PPO with extrinsic reward, that is the smaller version that I tested, which is what I'm going to show you the inference on. And if we compare that with the soft actor critic extrinsic algorithm, which is this gray bar, um, it's really weird because you can see that this sack actually started here, got really bad, and then suddenly got much better, and then kind of plateaued off. So, and I ran this pink one for a very long time, so I actually did run the soft actor critic for a while, and it started to plateau. So I stopped it early to avoid overfitting. But anyways, just in case your stuff's not training, maybe make sure that you go ahead and get over this initial hump. This isn't going to be the same for everyone, it just depends on your environment, but it could be the case that you're stuck in this local minima that you just need to overcome. Alright, so let's see how well we actually did here. Get rid of all this. So we have Rainbow Kitty, and I have dropped in our neural network. That's this .onnx file that we saved from our training, and I have dropped this down onto Rainbow Kitty, and we've dropped it over here into the model, and we've selected inference only. Super important, inference only. And when I hit play, Rainbow Kitty is going to adopt the brain we just gave him, and he is going to use that to make his behavior selections throughout the environment. So we can go ahead and take a look at this. So as we're going, we can see every time we hear that beep, it kind of scared me when it just beeped. But every time we hear that beep, it means that Rainbow Kitty acquired the target. So in the console, I went ahead and I printed out which tile the agent is landing on. So V is for violet, B is for blue, and then when it gets to target, it'll also pop up with target acquired in the debug log. And again, I should be clearing this debug log, but it's just for me to kind of see what's going on. So then we landed on yellow, we gotta get to another yellow, things like that. So he's actually not too bad. You know, you can tell he's pretty much learned to not fall off the platform, which is almost a pretty big deal, right? And if we want to see what input this agent is getting, we can switch to display 2. And it's pretty hectic for us because he's moving really fast. But if I stop the testing and I go back to heuristic only, we can just show you guys real quick what this looks like. This is me controlling Rainbow Kitty. So every time I turn, every time I turn, I'm too good at it. Every time I turn, it's gonna go in that direction that I asked it to go in. And see, I'm not even that good at not falling off the platform. So it actually is learned pretty well. There's probably some things that can increase the learning of this goal, but in general, I'm pretty impressed with how this environment turned out. So let's just go ahead and review what we have done today. So we had one agent, that is the rainbow cat. The target for that agent was to get to a color that is the same, to get to a tile that is the same color that the agent landed on. So the goal, the overall goal, besides just getting to the same color, is also to move to the closest target. So if there's two purple squares in view, go to the closer one if that's what we're looking for. And we achieve this by implementing an extrinsic reward policy of negative zero point 0.1 for each step, plus zero point 0.1 for each reaching the target, and negative 1 for falling out of bounds onto the black plane. The model that did the best, in my opinion, is the small PPO version with extrinsic reward. Curiosity didn't really help in this model, and that's probably because we actually don't need to search that much since we have so much visual information available to us. And that visual input was just one color camera that has a 10 by 10 size, and we also gave the agent the ability to know its own rotation so it can figure out where it's looking. So the output, the behaviors that the agent can choose from, is the continuous movement in looking direction. So as it moves, it's automatically going to look in that direction and go in that direction. So training and testing, we randomly dropped the agent on a color tile and searched for that target tile. So that's all for this environment, guys. Thanks for watching, and we'll be back with more tutorials and demos soon.